So today's live session, we're going to go over an example of using both strings, vectors, or strings and vectors in a pass by reference sense. We're going to implement using the first of the two templates. So as I said, strings and streams lecture, these two templates can be used for almost all file reading that we do. And so file reading falls into kind of this two different methodologies. Either a word by word will show that we don't really need to separate by line. It's whatever white space is in that input file, or line by line, where we get everything on a line, and then we parse out the lines into either individual variables or inside a vector into individual elements or some other data structure. So that's what we're going to do today. We're going to emphasize how reading files and then outputting based on a search. So we'll implement three functions: a search function that searches a vector, and a output function, which simply outputs the vector, and the acquireData function, which acquires data from the file. So we have those three prototypes that I copied in, and we'll just code dive here. So int main. So we'll have that basic setup. We have our terminal on the right because this development environment that I'm using today has terminal interactions. It's just compile through the terminal. Your choice of IDE, your choice of development environment might have a terminal window, or it might have a button to compile or keystroke or something like that. We also have our input files here. And so, as I said, different white space than what is in the slide. The slide's made for being a slide. We have a single space, we have a new line, we have a tab, and then this is supposed to have multiple spaces before it, and a new line as well. And so then we have an empty line at the end. And so all sorts of white space throughout this file. It's not a very condensed file. You could easily condense these onto a single line and save bytes in storage. But this is to demonstrate the difference of white space and how it doesn't matter when we're reading in with the extraction operator. Let me make this other window the proper size so I can see chat. So the first thing we want to do is acquire the data from the file and then output the data with our function. So we can easily write some loop to output the vector. We wouldn't need a function to do that, but it's very easy to just have a function to output our data structure in some way, and that way we can just call that function wherever we need to output the data structure, whether it's to check the values or to check whether something's working. Maybe we changed the values in some way, and now we need to just double check. And so, as I said before, a lot of the debugging in this class will be console-based or output-based debugging. And so outputting our data structure will help us know what's inside of it, whether we're supposed to see the change or not. Okay, so we have here our acquired data. We actually need to include several things for our code. So first, we're using strings. So let's include that. Then we're going to use input and output. So we need the input output stream library, and we're going to use file stream. So we're going to include, so we have that, and obviously we're using vectors as our structure where we're storing that data. So we have to include the vector library as well. So those four things. String is actually included in IOStream. So if we left this off, it would be included, and we would be able to use our string data type here still, but it's not going to be clear that that is its own library. It's just included as a redundancy within IOStream because it needs strings itself. And so we want to be clear to whoever's reading our code what dependencies we've built into this specific file. So we have up here our description, a quick description of what is going on here. So auto documentation, there's programs that do auto documentation. And so auto documentation looks for certain things and certain flags in your files and then creates documentation from them. And so here we see 3 different tags for auto documentation. And so I don't often run the auto documentation on my files. However, after building programs for so long with auto documentation and using that methodology, it just becomes second nature to kind of use these tags. And then it also makes it easy to run that auto documentation if you need to. So first thing we need to do within main is create a string file name, know where our file is. We could get this from input cin, so we could do that as input, but to save on constantly typing when I'm running my program, I'm just going to hard code it for now. And so we have our file name, and then we need a vector, strings, and then we're just going to call that data vector. So then we're going to acquire the data. And so acquire data, we see on line 13, the prototype. So a function prototype is a lot like the function header. However, it does not require the variable names. A function prototype just tells the compiler this function is defined somewhere. So if someone calls it, link it to that definition. So that way you don't have to define all your functions between main or in a proper order so that you call them after they're defined. We have that prototype, so now we can define the function down below main or in another file if we're trying to do multiple files. So here we're just going to define it below main. So acquire data takes 2 things, a reference to a string and then a reference to a vector of string. So we have both of those. We have the file name as well as our data vector, and that's what it's going to take. So it passes along these variables, the memory, since the reference parameters, the memory addresses to those variables. The first one is going to be constant. So our file name is constant because we don't want to allow acquired data to actually change the contents in that variable. We simply want to pass it along the value. And since it's a string, since it's an object, our choices are either constant and pass by reference or just pass by reference. And so here we see both of those being used. We don't know how many characters are in our string, so we want to pass it by reference. It could be 1 billion characters long. That's a really long file name. However, this is the standard we want to stick to. So we want to pass by reference, and then we choose constant based on whether that function is going to actually change the values in that variable. And so we do not need the variable names in our prototypes, but we do need them when we define our function. So our prototype, we can copy, and then we want data and our file name. We don't need to use the same variable names as we have in main. That's a big thing to understand, is we don't need to have those exact same names. So to do that, we can have different names or the same names, but they are local names that belong to this function. They simply are reference parameters that point back to the memory addresses of the variables in main, but the names are local to the actual function implementation. So normally we would want to open the file, check if it's open, check if it opened correctly. So we see this example template, and that's what we're going to use. There's no check if it's open step here. If you're writing robust code, you would check if the file was opened properly before going through in a loop and trying to get all the information from it. We'll skip that step here too, just for brevity. So normally your process is to open the file, as we saw here. We have that input.txt. We have to create an ifstream object, and we're going to use the constructor to open the file while that object is being created. So open is called with the constructor when we pass that input.txt string to the constructor. And then we have our simple value string because we need to read into something. And then we just have our loop. So our loop says what stream are we extracting data from, where are we putting it, and then we want to build our vector. So we could actually go through and build our vector one at a time. If we know the size, we could have used the actual .at here, but we don't know, that's not the name that we're using, data.pushback. So we're going to build it element by element, and I can't type, so value. So here we just have a vector being built element by element. We read in with our operator here into the value string, and then that value string gets pushed back into the vector. And then finally, we want to close file as soon as we are done with it. So it's good practice to close the file as soon as we are done with it, because otherwise it just sits open and lingers throughout your program. If this is the only place we're going to be reading it, we don't need to have it open and sit open. And so as noted in the strings and streams lecture, this operator, this operation here, when it fails to get a value, so we see our input text, eventually it will get to this blank line. It skips all white space, which is why we don't care the type of white space. It's word by word. This operator here skips all white space, and then when it fails, it will return false, that it couldn't do the operation, and then the loop will exit. So the loop will terminate because of that. Okay, so we have that acquired data that then we want to output our vector. Okay, so let's see if this compiles. Make sure before we move on to the output. So we're just going to compile with C++. It did not compile. Okay, the terminal, so let's compile now that we actually put our namespace in here. So that error, all those errors were relating to that one line of code that was missing. Yep, there we go. Now it can run and execute, but we don't have anything done, right? We don't have this output vector done yet. We want to write that so that we can actually call it. So void output vector. And now we just want a constant vector of strings, and we're going to simply call it v. And we want to simply loop over that vector and output each element on its own line. Okay, so a few things to note here. So we have the output vector. I will put the comment in for acquired data. So we should have acquired data. Write that comment so it demonstrates the auto documentation for functions. So like I said, the auto documentation allows us to put a brief in, and that brief will now be tied to this function. So using file provided, not namespace. Auto typing is not working in my favor. Storing into a vector. Okay, so storing into a vector, and we have two parameters. So the function auto documentation has an @param, and then we put the name of the parameter, and then we put a brief description, very short, file name to open. String at, very short, like I said. There's also return at return, but we don't have a return. We just have another parameter called data. Oops, forgot my. So we have three things for this auto documentation. If we were to run it, we have the brief for the function, and we define what each of the parameters are. This is good practice, even if you're not using an auto document, right? Because we now can read this function header and all the comments and know exactly what is going to be needed when we call that function, and kind of what is the purposes of these parameters. And we don't care about the actual contents of the function. We don't care about the implementation, just how to actually call it. So here we have two. So someone asked about the ampersand after the const, so we use it twice here. So here we are using a vector and we're passing it by reference, but output vector does not change the contents of the vector. It simply uses the contents. So we do not want to allow the function to change it. So when we have that, let me make sure this compiles. I will show you the error. So that compiles. So if we try to change our vector, we will get an error, gross error, a lot of spam in the terminal, that basically says we have in output vector, and depending on your terminal width, it might be easier to read. At line 41, you're attempting to use the assignment operator on a constant. And so allowing us to use that constant allows us, the compiler, to check your work and make sure you're not actually changing variables that you shouldn't be changing. So then we have that constant. So we're always going to pass an object by reference. So whether it's a string object, a vector object, or some data structure that we're working with, we always want to pass that by reference. And then we have to choose what the function's purpose is. If the function's purpose, like in acquireData, is to update that vector and modify its contents, we can't have it be constant. But if its purpose is simply to use the contents of the vector, use the values that are in this data vector, we don't want to be able to change it. And so allowing us to use const allows the compiler to check our work, essentially. And this is commonplace. This is a common technique because as we get bigger and bigger programs, as you do other classes and in this even in this class with bigger programs, you don't want to accidentally be modifying your data when you're not supposed to be. So choosing that constant allows you to prevent that. As you do in other classes, if there's group projects or programs where you implement part of it and then someone else implements part of it, then you are guaranteeing that they are not allowed to change whatever you're sending by having that standard of this is a constant that I'm providing to you. You're not allowed to change the actual values. You simply get to use the values. Okay, so we have that implemented. I think I got it in main, so we can compile now and execute. So we have banana, 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 banana. So there's a logical error, there's a lot of bananas. Obviously, if we look back at the input text, banana is the first thing. I forgot to use my I here. Shouldn't be using 0 all the time. So now we have banana, apple, pear, grape, avocado. And so we see we got all of that data read in from the input file, input.txt, and then stored in the vector because our output vector is called in main. So if we want to call it in our function, we can call it after each data is inserted to see it grow if we really wanted to. So as I have previously said, a lot of our debugging will occur in print debugging. So print debugging meaning we're going to output to the console and then debug based on the information we get in the console or in the terminal window. And so here we call output vector with our data vector, which is not the name inside this function. And so now it should call it every time and as we see it grow. So banana, then banana, apple, pear, and then banana, apple, pear, grape, banana, apple, pear, grape, avocado. And then finally, we're in our main function. So the reason we want to pass by reference here is to update our value. So if we don't pass by reference, that creates a vector that is a parameter for acquireData. It is a copy, it's local, it has its own memory now for this local function. And so when we execute without our reference parameter there, we can't have to have a function prototype that matches. If we compile and execute without a reference parameter, we see the vector grow, but then we get the output in the main function, there's nothing there because we did not return anything to main, it's a void function. We also simply grew the vector inside our local function area, our local function stack. So it has all that information as we see it grow inside the acquire data, but then when we go back to main, it's gone. And so we want to pass by reference there, so we update a vector that is in the place of the function call. So we could also, we discussed returning by reference, we could return a reference, but it's easiest here to pass by reference and use that as a return value. So we're going to update the vector that is provided. Update my prototype again. So I saw a question about this uint here. This is an unsigned integer. You could also type unsigned, and that would be an unsigned integer as well. This avoids any warnings. So a lot of times compilers, both how we compile code in lab as well as on SciBooks, turns on the warning flags. And so this is a comparison between I and size is unsigned. So size will be unsigned, which means it can't be negative. So in order to avoid a comparison between a number that can be negative and a number that can't, we want to make I be that as well, unsigned as well. I simply use uint, which is an unsigned integer. You could say unsigned int, extra parentheses. So that all works. That's an unsigned integer. That's a really long. Unsigned also works and defaults to integer. The shortest of them all is uint. So that way we can just use uint there. Size t also is an unsigned integer. So we've seen size t in slides as well as SciBooks examples uses size t. These are all defined type definitions, words that C++ has inside that standard namespace. And so they all point kind of to the same thing, unsigned integer. So that way we don't have to type the whole thing out. So, okay, we've output our vector. Let me save and compile. Now that we fixed the code to be the actual reference parameter again, we see the output in main. And the last thing we want to do is implement a search function. So this search function will search for a specific letter and output all the foods with that specific letter. And so in main, we want to get a letter from the user. So char letter. And then we want to, so we'll just simply get that from input. Separate out in our terminal a little bit with a blank line, and then we will get a letter from here. I always put an end line after my inputs. We'll see why that is with the input redirection in a second at the end of this execution. So I'll show you input redirection so that we don't actually have to type all of our inputs to our file. So if we, or our program. So if we're executing with a lot of different inputs, it's easy to use input redirection to allow us to not have to type all that out every single time we're trying to execute our program. So we have our input, we get a letter, we want to search the vector. So it's searchVector's job will be to simply search for the letter and output information. So it's not going to return anything. It's simply going to output the information as it's discovered. So our search vector, let's copy the prototype. The search vector will be a character, and then we need a data. We're just going to call data there. Okay, so search vector is simply going to search, like I said, search all the words in, for all the words starting with a specific letter. So here is an example function comment without the auto documentation. So you notice I don't have brief, I don't have app parameters. You should go through and define all those things, but for brevity of this video recording, this implementation, I'm just going to have that comment that defines what this function is going to do. And so we want to search through the vector, and we want to output an error when we don't find it. So the first thing we can easily do is output that error. So when we're trying to write our function stub, we could just have this, right? So this will compile. It's a void function. Oh, I'm missing a token somewhere. Oh, this compiles, executes, and does nothing because our search function doesn't do actually any logical search. So we can have our search function implemented in steps. The first step could easily be the error step. So we want to output an unfound, no data, starting with that character. So if this, we can have a flag. So it's a function. So if we could return early from this function, we could easily output our string right there. Okay? So if we somehow returned in our loop, and whenever we found the data, outputted it in return, if we only want to output the first item. And so searching predicate functions, searching functions, things that only look for one thing, and as soon as they find it, they are done. You can exit the loop, right? So exit the loop, and often if it's in a function, we will simply return. And so we're going to return early. Here, we're outputting all the words that start with the letter. And so we can't return early. So we need a flag to say whether we found stuff or not, because we need to output that error. So we have that flag. We started at false. In most cases, your start value will be based on what your name of your what your name of your Boolean variable is. In most cases, for searching or for looking for things within a data structure, you haven't found anything, you haven't discovered anything at the beginning of your function. So most often you will start that predicate, that Boolean variable, as a false. And so we do not want to do a comparison here, as we said in the style guides. We don't want to say, oh, if found is false, do something. We simply want to say, if we didn't find it, then do something. Indent these now. So we use our proper style of not doing a comparison to get a true false when we already have a true false value. And we simply want to say, okay, well, when we didn't find something, so when this is not found, right? So not found, then we output our error message. So that will compile and execute. And we see, if I enter a character, it goes through that function and says no data starting with A. Because we haven't actually implemented our function, there are two things starting with A, but obviously we don't have that flipped to true in any form. So now we're just going to go through our vector again. We're going to loop over and search for that specific character. So if we go through and check v.at_i, that is the whole string. So this at call gets us a string from the vector. Now, every string also allows us to call .at on it, and that would get us a character from that string. And so this first at gives us the actual string, the element from the vector, and then this second at gets us the first character within that specific string. And we want to compare it to our letter. So when we discover that first letter is a match, what we want to do is output the word we're looking at on its own line, and then update our variable to say that we found a match. So now we're updating. So if this branch is executed, if we go inside this branch, we will flip our Boolean variable to true, which means when we exit this loop, this will say if not true, so that will be false and skip over this branch as well. So that's how we can flip our Boolean variable. We discovered something, so then we don't accidentally output the error. Compile again. I have v not declared in the scope. What did I call? Change it up here because it's clear that way because I used v in here. So again, this is a searching of a vector for a letter. It doesn't know what kind of data. It's just a vector of strings in this case. So we don't need to call it data. We can just have it be a general v vector. Save and oops, program and compile. Okay, so we have the execution that starts with our output. Then we hit A and it runs and we actually see that we only output apple and avocado. If we execute it again and type B, we will get banana. If we execute it again and type C, we get no data starting with C. So we see that 3 different executions, and we're typing with user input there. So as I said, with input redirection, we could put our inputs, which simply is we will put our file name here, and then and we will change our program slightly to not have file name to start with. And so we will simply say enter a file name. So instead of having to type that every time, right, we didn't really change our code. So we changed our code to use input. So now we say input.txt, and then if we say p for pair, it'll output p. Or output the pair because that's the only p start. Now we want to demonstrate input redirection here. So input redirection means that we're not going to actually type our input here on the console. We're going to use a file that has the inputs. And so instead, we will type our program. We will use that left arrow to say get the input from this file and send it to the program as it's executing. So in r.txt is the name of my input redirection file. And so when we run it, we see that it executes correctly, and it simply acquires the inputs from this input redirection text file. So instead of having to type them, it automatically pulls from this file. And this is what computers will do to run your program if there's input or if you're using input redirection. So Zybooks does this when it's testing certain programs. In addition to using file streams, it will use input redirection, which is why we have that new line character being output after the cin. So if we run it and type all that input, we see here a blank line, but we do not get that blank line when we run it with input redirection because there's no echo of the typing. So there's no echo to this terminal of the actual typing, whether it's the input.txt, we see we don't have that occur here. We also don't have the enter press at the end of the line. So we don't have that echoed, so we don't get that blank line. So if we take out that blank line to show that why we do that, we compile and execute with input redirection. So if we execute without input redirection, we see input.txt and then and we notice we don't have that blank line after input.txt, but we still have that enter press because it gets echoed when I press enter. However, if we use input redirection, we don't get that echo. So now the output in main function, so that line that gets output right here, is on the same line as enter the file name because there's no echoing of those characters, which is the enter press. And so we end up with this condensed output that doesn't look like it should. And so a lot of times we will, in Zybooks and in our programs, we will want this end line after a cin so that when we're using input redirection, it still looks like a good program and clean output. So that's just, we compile again, use input redirection, and we get that clean line by line output. And so, okay, Yes, so somehow some of the questions I'll go through right now. So we have this program implemented acquireData, outputVector, and searchVector, the three functions using reference parameters, constant reference parameters, and file streams to get the data, as well as using demonstrating input redirection, which can be very useful if we have a lot of inputs in our program and we don't want to type all that. That's often the reason to use input redirection, is you don't want to sit there and type and accidentally screw one typing up, and all of a sudden you have to run your program again because you typed the input incorrectly. So that's a useful input redirection, can be very useful for executing your program. Everyone have a great day.